You can build a functional Android application from scratch without writing a single line of code. All it takes is a plain language instruction. To set up this environment, you only need 5 elements: a Google account, an AI text generator like ChatGPT, a local computer, an Android phone, and a physical data cable. Removing the syntax barrier means you can skip learning programming languages. You can convert a raw concept directly into a deployable mobile app in a matter of minutes. We start by taking a loose idea, like a shared expense tracker for roommates, and running it through a standard text AI like ChatGPT. Our objective here is to have the AI write a structured system prompt for us. We need to define specific parameters in this blueprint phase. We instruct the text AI to limit the app to offline use, set up simple naming conventions, and establish specific rules for the logo and splash screen. This text output becomes our foundational architecture. The downstream Google compiler will only generate the features and logic that we explicitly map out right now. With the blueprint complete, we copy the entire text block and move over to the Google AI Studio workspace, pasting it into a new Android app project. Once we click Build, the Studio begins parsing those natural language constraints. It breaks the text down into user interface elements, logic paths, and databases, and auto-assembles them into a working mobile architecture. Within a minute or two, a live preview emulator loads directly in your browser. This lets you test the generated logic before you commit anything to a physical device. We can immediately verify the data entry sequence by creating a test group, say for a specific dorm room, and adding multiple member profiles to it. Next, we run a mathematical validation test. We log an expense, like a $500 lunch paid for by one person, and check to ensure the application evenly splits the integer across the rest of the defined user group. This virtual validation phase guarantees we catch broken logic arrays early. It reduces our iteration time by keeping faulty math off our physical hardware. Now we move the application from the web browser to the real world. This requires establishing a deployment bridge by connecting your Android device to your computer with a physical USB cable. Before the phone will accept the file, we have to access the System Information panel to manually enable the developer permission settings within the Android operating system. You do this by navigating to your settings, finding the About Phone menu, locating the device's build number, and tapping it exactly 7 times in a row. If you skip this sequential procedure, your computer will not recognize the device as a valid testing environment, and the installation fails. Once developer mode is active, a prompt appears on your phone screen. You must explicitly grant permission for incoming USB debugging data to flow from the computer to the device. Mastering this local deployment bridge is the final technical hurdle. It is the step that turns a theoretical web project into a native, usable application. If you want to apply post-generation modifications, like changing the entire app's color theme to blue, you simply submit a secondary natural language command directly into the AI interface. The Studio generates the updated build. You then push it through that established USB connection to overwrite the original version on your device. This means you can iterate and execute immediate visual pivots without ever manually manipulating the underlying CSS or XML style sheets. Once the installation is complete, you can disconnect the cable. The finalized application runs natively and entirely independently on your device hardware. You now have a complete application file. You can distribute it via local peer-to-peer file sharing on WhatsApp, or scale it up for formal ingestion into global marketplaces like the Google Play Store. AI compilers have shifted the primary bottleneck of software creation. Developers can now focus on conceptual problem-solving and logic structuring instead of technical syntax mastery.